Now I'm glad to introduce our third speaker, Ms. Xue Jing from the Biologics PD and MSAT Department of ProBio. Ms. Jing graduated from Shanghai Jiao Tong University with a master's degree in bioengineering in 2019. During her master's period, she mainly engaged in autophagy and mastered various biologics experimental skills. Prior to joining ProBio, she worked at Wuxi Biologics and gained extensive experience through the elite program by rotating in manufacturing and PD departments. She later transitioned to the Clinical Manufacturing Technical Support Department, where she was responsible for the technical transfer of clinical and PPQ projects. After joining ProBio, she is responsible for technology transfer work of the antibody MSAT department. In this talk, Ms. Jing will be discussing the topic about enhancing technology transfer, strategies, challenges, and the best practices. Now I will hand it over to Ms. Jing.
Hello, can you see my screen?
Yeah, it looks great.
Yeah, okay. I'm Xue from MSAT ProBio, and my topic is enhancing technology transfer, strategy challenges, and best practice. And this would include three parts. First is the effective approaches to tech transfer, and next is the key challenges and the pain points in tech transfer. And just in order to better understand, I have placed the sharing of the cases after each key point's explanation. And finally is the risk management strategy in technology transfer. And the first is the effective approaches to tech transfer. And these two paragraphs are about the design of tech transfer in PDA 65 and SHQ10. And as we know, the tech transfer is mainly the activity carried out between sending unit and the receiving unit. And the most important parts are to completely transfer the technology from sending unit to receiving unit. And the technologies include process, analytical methods, and maybe include materials and equipment and so on. This is the tech transfer can be classified based on the product's life cycle and the set types. And the tech transfer from the clinical to the clinical stage, except considering the product process and the analysis method, just like I mentioned before. And the most important thing is material management. And currently, most of the tech transfer in ProBio is clinical to clinical. And as for the department to commercial tech transfer, which often begins when the products is in clinical phases 3 and involve the transfer of the full scope of CMC requirements. And in this stage, I think the products and the process and the testing method, just like the analytical method, should be updated in parallel with the tech transfer. And it can be defined the final CMC requirement. And this would be benefit for the commercial line. Maybe just like the PPQ readiness and the process validations. And during this stage, PD may conduct many PC experiments, and the MSAT department analyze the key parameters based on the design and the results from PC experiment. And finally, they will confirm the CQA, CPP, IPC, and IPT by the FMEA. And currently, ProBio have experience in the PPQ project. And the third type is commercial to commercial tech transfer. This may involve scaling up or down based on the production requirements after the commercialization. And if we classified based on the subtype, and the tech transfer can be divided into internal to internal, and internal to external, or external to internal, or external to external. And as for the internal to internal, in ProBio, it may be the tech transfer from PD department to M-site and then to the GMP department, or between the different sites, just like Zhenjiang site and Nanjing site. And specifically examples will be shared later. And the external to internal transfer can be the process developed by the client, and then they transfer the they just show their process to ProBio, and then we generally we would have a commercial confirmation run for the process log, and then we got the external to the internal tech transfer. And this page is an extension of the previous one. And the tech transfer runs through the entire life cycle. And the tech transfer is defined by 6 parts in the regulations. However, in practical application, we do not distinguish in such details. There is a certain overlap in each stage, and we will carry out tech transfer according to the overall time of the project. And as we can see, we usually do the, sorry, I can use this. We can see in the preclinical development, and then we go on to the phase 1, 2, 3. And in phase 1 and phase 3, in phase 1 and phase 2, we usually do the scale up and process optimization. And in phase 3, we can go the PPQ, and we can do the process characterization and the process validation. And for the commercial production, we can do the CPV monitoring and optimization. And this is a tech transfer in ProBio. And we usually have these 5 steps. And first is, we will build a tech transfer team and hold the kickoff meeting and make us familiar with ourselves and understand the function of different SPLs. And after the process development reach a certain stage, M-site will draft a BOM based on the data provided by PD department and send it to the planning team to assess the quality of the materials and the lead time to ensure that the material can meet the production needs. And after the process is logged, M-site will once again confirm the process parameters and the risks through a meeting with the PD. And they will conduct a gap analysis based on their own knowledge of process scaling up and down. And meanwhile, I think we will analyze the materials and the equipment and draft the PI, and it just a draft. And then we will organize a meeting with PD to conduct the technology transfer and the training the GMP team to ensure they can just conduct the production as the process instrument. And the production department will just batch record based on the PI. And finally, in the production stage, the operators will strictly forward the batch records for product operations. And the M-site and the PD can provide on-site technology support and troubleshooting. And finally, we will do the comparable analysis to ensure the tech transfer entirely completed. And next part is the key challenges and pain points in tech transfer. And we usually focus on the risk of tech transfer from 6 aspects. And the risk assessment will be conducted from people, equipment, materials, methods, environment, and testing. And the PD will give instruction on development flow, and MSite and MG are both involved. And I just want to show this form. Sorry. Oh, sorry, I just can't click it, so we can go on next page. And we usually focus on the risk of tech transfer from 6 aspects. As mentioned earlier, for the earlier stage projects, materials are a relative large risk point because we have confidence in the internal control of process parameters and testing methods. But the material shortage are influenced by so many factors. So we will draft a BOM based on the information provided by PD department, maybe 2 or 1 month before the GMP production. And we will send this BOM to planning team, and this will confirm the lead time for the materials based on the BOM. And this is just the case sharing for the material. Because for the resupply our cross-site tech transfer, we also need to analyze the difference in materials. As for the materials with medium or higher risk, we will also take measures such as conducting small-scale small-scale experiments in PD, and most of these materials replacement will be fully assessed by the change control. And as for the change of culture bag, we will conduct this by changing control and the risk assessment to analyze the gap between the materials to ensure the change is acceptable. And we also could do some measure to avoid and decline the risk. And this slide is the equipment preparation in ProBio. And in tech transfer, different equipment may be used for PD and GMP scale. And different equipment may also be used in different sites if the project changes the production site, just like I said before, Nanjing site and the Zhenjiang site. As for this, we will conduct analysis of key parameters and the differences. And the risk assessment will also be used to evaluate the difference in these devices. And this is a case sharing for equipment. It's a RM vs WAVE. And for example, the changes between RM and WAVE equipment. If this change occurs in a project that has already been produced in our facility before, we will control the risk in the equipment by change control. And this is always in the beginning of the tech transfer. And just like this red circle. Because I have said in the regulation, we have 6 steps in the tech transfer. And at the same time, we will also trace the cell growth and the cell metabolism and the protein quality before releasing the product. And we will doing this to determine their comparability. And this is a case sharing for bioreactor. And as for this part, I want to say this slide mainly present the parameters between the different bioreactors, and we have a table containing the parameters of all bioreactors, which can be used to calculate the PV value and the airflow. For example, we can enter our agitation to get the equivalent PV in different bioreactor. So I just want to show this this table. Please wait for a moment. Oh, sorry, it's crossing this screen. Yeah, we have this table, and if we just enter the PV level or we enter the agitation, we can got the different PV value and agitation, and we can just use this table to make the different bioreactors have the equivalent PV and the equivalent airflow. Yeah, and oh, sorry. And as for the method for scale up, and this include the cell culture and the purification. And as for the cell culture, we have the independent on scale or dependent on scale. And we can see the scaling up parameters can be pH, temperature, and feed ratio, and which can be directly applied to the large scale production. And the other type is scale related, such as PV, gas, airflow, and so on. And this would be need to be calculated based on the scale and the type of the bioreactor. And this is applied to the table shown before. And as for the purification, we have the focus is on yield and the product quality, such as purity and activity, and the other key attributes. And this is a summary about what I have said before. This is about a challenge in upstream and downstream in tech transfer. And we would analyze the root cause and find the solutions for them. And this is just a summary of and to get the root cause and the solution to lead to FMEA. So the third part is the risk management strategy in technology transfer, which is also the FMEA used normally. And this is the scoring criteria. It has 3 parts. First is severity, and next is the occurrence, and finally is the detection. And this part is the scoring. And I also just want to say this. As for the best practice for effective FMEA, we need to do the cross-functional team involved, and to pay attention to the historical data and dynamic updates. These 3 parts is very important in the scoring. As we can see, the first process step, the media preparation. And as for the media preparation, we may have different failure mode. As you can see in this table, is the incorrect weighting maybe cause the failure mode, and its effect is cell growth inhibition and the batch rejection. and maybe someone could give this severity is 8, and give this occurrence is 3, and give this detection is 3. So finally, we got RPN is 72. And we will, after this scoring, we will have the mitigation actions just to make this failure mode reduce this failure. And I think we also have so many failure mode in media preparation, maybe the pH testing, or the missing time, or the missing speed. They could all be the potential failure mode in this chart. And we can just use the FMEA principle to analyze this kind of situation, and finally got mitigation actions. What's more, I think I just want to say good tech transfer can't without the effect of various departments effect. So the best practice is involve these 5 parts, not only the first 3, and but also the link to control strategy and focus on the high RPNs. And about PPQ, I just dropped the PPQ here is just want to say in PPQ strategy and the documents, we widely use the FMEA to analyze the parameters or the situations. So if we have the opportunity in the future, we can go on talk about this PPQ strategy and documents and how the FMEA used in the PPQ strategy. And as for this report, the identify critical risk and priority the mitigation and ensure the product quality, I think is the most important purpose of the FMEA. So that's all. Thank you.
Thanks for Ms. Jing's sharing. Let's move to the Q&A part. When you type the questions, we also kindly invite you to submit your question in the Q&A panel, and invite you to follow us on LinkedIn and the Kakao channel for more online resources and updates. Okay, let's take a look at the first question we received. When the overall time for development and production is very short, how to control the technology transfer?
Yeah. This just like the slides I said before about the materials. We can take the upstream for example. And first, we will determine the materials for our GMP production according to the materials selected by PD, and provided them to planning team as soon as possible to ensure the sufficient materials before GMP production. And during the process of PD development, we will continue to track or replace these materials. And secondly, we will maintain once the cloning and media and the data train are confirmed, MSite can ask PD to summarize the process data of the data train and send to us. And MSite will determine the process parameters based on the existing data and draft the confirmed part of the PI, adjust the process instrument, And this document will be reviewed by PD, GMP operators, and QA, and to ensure the process has already effectively transferred from PD to GMP. And we will training the operators in GMP. And then PD can continue do the process of N stage. And during this part, MSite would update this parts of the process parameters to the process instrument. And since most of the projects in ProBio is the early stage, so the first batch of the GMP production is mostly a tox batch. So we can accept this tech transfer like this, and such as the separate transfer from seed train and to N stage process mentioned above. Yeah.
Thanks for your answer. Thank you. And the next question is, could you please sharing how to calculate the materials and estimate the quantity in the early stage?
This question just after the first one. Usually, we will have a platform process development strategy, and we can calculate the basic demand for some materials and provide sufficient safety factors. And if the individual projects require a temporary change of the materials, and if the material is in the platform's stock, and we can directly use it and then purchasing it for stock later. And if the material is special and has been purchased by the other projects, and fortunately the usage time is later than the current project, and we can just use the material after ensuring the delivery time could meet the need of the other projects. And if no project is using the materials, I think we can connect the supplier to ensure the lead time as soon as possible. Yeah.
Thanks for sharing. It's really seems that we need well-organized and well management. And here is the question from attendees. Let me check. When we transfer analytical method, is there any tool for comparing results of two sites? For example, mean plus 3 sigma or t-test, etc. You can find this question in the chat panel.
We will use this kind of 3 sigma or t-test in our change control, and we will have a risk assessment for the results comparing from the two sites. And generally speaking, when we have the transfer from the from two sites, as in ProBio, we have Nanjing site and Zhenjiang site. We will draft the change control to analyze all the different parameters of the equipment or the materials, and to have a risk assessment. And if we do need analysis some results of the data from PD or from GMP production, we can use the 3 sigma or t-test.
Thanks for your sharing. The next question is, what are the scale-up factors applying for the scale-up batches during the tech transfer, and how do you control, if any, arithmetical changes?
I think I have set some factors in the slides in the method scale up, and we just take sample for upstream. We need to have some parameters independent on scale, just like pH, temperature, and feed strategy. We can just send these parameters equal to the from PD and equal to the GMP parameters, and some parameters depend on the scale, and we need to just calculate the PV or the airflow, just like I show the table I showed before.
Okay, yeah, thank you. That's all the question we have by now. Thanks for Ms. Jin's sharing today.
Yeah, thank you.